Messy.
Yeah, an airplane is flying on a compass heading bearing of 340 degrees. Yeah, snip the problem. Why don't you snip number 43?
Okay.
That'll work. If you just snip it, then
I was gonna put a sticky note up, but hey, I guess that'll work
yeah, let's
too.
just snip it. And then maximize the screen. Awesome. Okay, now, come on. There we go. All right, so airplane is flying on a compass heading of 340 degrees. Okay, so compass heading 340, that's like this, right? You got 0, 90, 180, 270. Are you familiar? Do you remember the bearing scale?
Vaguely, but for the
Okay,
most part,
so you're coming all the way around here for 340.
yeah.
Okay, now, um, so the length of the vector is 325. Okay,
Okay.
so that particular component form vector, all right, remember, if you treat it like, if you treat that like a right triangle, the components would be the x and the y, which would be the legs of the triangle. Now, those components would be negative, let's see here, negative 325 cosine. Now, what's the angle inside here? Okay, let me see. I'm gonna think about this for a second. If that's 340 take away 270, what would that be? A 70-degree angle?
You said
340,
take away 70 or 270?
270.
Yeah, it was
270.
70 degrees.
Okay, so that's 70 degrees. So that means, come on, get rid of that triangle. And we have 325 sine 70. That's my x and my y.
Okay.
Now, the next part, a wind is blowing with bearing 320 at 40 miles an hour. So it's kind of doing this a little bit at 40. That's kind of a
Okay.
little. That's kind of a little bit exaggerated because 320 is, if you think about that little triangle right there, it's got an x and a y value. It's got a negative x and a positive y, so that would be negative 40 cosine. And inside that triangle, there's a little angle right there. And let's see if that's, so that'd be 320 take away 270. So what's that, 50?
Yeah.
Okay, so that'd be 50. And then positive 40 sine 50. So all you have to do is add these two vectors together. Now, I should say, so part A goes with the first line. Find the component form of the velocity of the airplane. That's part
Okay.
A. Part B is find the actual ground speed and direction of the plane. So in other words, we have to find the components of these added together. So we'll have to find the components. And then after that, we want the magnitude and the direction of that.
Okay.
And I'm guessing, since they're dealing in bearings, that they want it listed in bearing form. So I would have to keep that in mind when doing this. So if I use my calculator, let's see here. So negative 325 cosine 70 plus negative 40. Oops. Somebody's barking up a storm.
Yeah, that's my 3 dogs.
Negative 40 cosine 50 So I got negative 244.43. 325 sine 70 plus 40 sine 50 gives me 241.02.
What mode are you in? Because I got like completely different answers.
Oh, you're right. I was in radian mode. Good call. Good call.
I know, I was about to say, wait a minute.
All right. You got me. You got me. Let's try that over again. Okay, so well, you actually have to change the mode before the answer will change. Otherwise, you get the same thing. 336. Ooh. 336.04. Does that sound right?
For which one?
For the Y.
Yeah, I just got 336 even when I added both of them.
I got negative 136 point. I don't know if you want to go 9.
Yeah, that's what I did.
Okay, all right, we'll go with tenths. That's fine. Okay, so got those two. Now I need to find magnitude and direction. Are you comfortable doing that?
It's just you take the square root of, yeah, I know what you mean.
Okay, so.
But like for direction,
yeah.
How would you do that? Because you were talking about how you'd have to do that differently or something.
Yeah, so magnitude I ended up with 362.8 for the velocity of the plane.
Okay.
Okay. Now, direction. So let's think about this. We have, and I'm going to use a green arrow to go from here all the way to there. You see the green arrow?
Yeah.
Okay, so this has an x value and a y value. That x value is negative 136.9. That y value is 336. Now, how do you find this angle right there? Don't we do the inverse tan?
Yeah.
Of 336 over negative 136.9. So if I invert that tangent, I should get, my calculator's giving me negative 67.8, but I know that it's really 67.8. Okay, so that's that angle in there, 67.8 degrees. Now, to find direction, we need to figure out what that bearing is. So that bearing is going to come around. So the bearing would be 270 plus 67.8.
It's like 337 maybe.
Yeah, 337.8 is your bearing.
Okay. Okay.
This is hilarious to listen to the dogs in the background.
It's just one. He doesn't stop, and I don't want to scream at him because I know he's going to keep going.
Exactly. Plus, this will be on YouTube, so you know.
Oh my god, I forgot about that.
You'll be famous. Your dog will be famous.
Yeah, if Bart's name gets out there.
So, does that help you?
Yeah, and then the other one, it deals with a boat though, and it doesn't give any like.
Well, can you snip that one?
Yeah.
See if we can at least set it up. Okay, ship is heading due north at 12 miles an hour. Okay. So that's easy. That's the vector 0, 12. Is that right?
I'm not sure. You tell me.
No. I don't. To find the components, that's not right. What am I thinking? Now, we can use so like, 12 cosine 0, or 12 cosine 90, and 12 sine 90. Now, actually, I think that is going to be 0, 12. Yeah, okay. That makes sense. The current is flowing southwest, okay, southwest at 4 miles an hour. Okay, now if you would imagine kind of an origin right there, okay, and figure out that angle right there.
Wouldn't it just be like 180 plus whatever that is?
Yeah, 180 plus 45, so it'd be 225. So this is 4 cosine 225, 4 sine 225. Now you'll notice in this particular example, I did not use any negatives. But you know that if I go left and down, they're both negative, right?
Yeah.
Okay, because I used 225, it automatically will spit out negatives. Now, if you wanted to use just this right triangle, this 45, 45, 90 right triangle, just like that, and that's all you wanted to use, we could do this problem with a 45-degree angle, but if I do it that way, I have to put the negatives on myself.
Gotcha.
But if I use the 225, it'll automatically take care of the negatives. So it's up to you whether you want to just use quadrant 1 angles and, decide on your own whether you got positives or negatives.
Okay. So did you get, like, when it says southwest, is that how you got the 45?
Yes, southwest. So, if you've got west going here and south going here, southwest would split the difference.
Okay, that makes sense.
Okay.
Yeah.
All right, now. So you would need to add these vectors together, okay? And then what you'll end up doing is you'll find the last part of this, which is that blue one right there, blue triangle X, Y. And then the bearing is going to be this angle that comes all the way around here. Now you would want to use the inverse tangent to find that part. And then you would need to add that to 270 to find the actual bearing.
Okay, I gotcha.
Okay?
Yeah.
Does that help enough?
Yeah.
Okay.
That makes sense.
All right. Do you want me to go through these calculations, or can I call it a night?
No, you're good. You can go ahead and you're fine.
All righty. We'll see you tomorrow.
Yeah, thanks for the help.
Yeah, no problem. It's been a long day, and I've still got papers to grade, so.
That's an oof.
Yeah, that is an oof. Oh, my goodness.
No, I should never say that.
That is such an oof. Oh, my goodness. You're right. That's a big oof.
That's an oof on my part, too.
Oh, okay.
All right, see you, Staley.
Yeah, those kicks are dripping.